As you know, an arithmetic sequence is a sequence in which each term comes from the term before it by adding the same number each time. So I've written over here the definition: add the same number d each time, and d is called the common difference. Now the nth term for every arithmetic progression is this. It's a sub 1, the first term, plus n minus 1 times d. So to find the nth term of in an arithmetic progression, it's the first term plus n minus 1 times d. 1 less than the term number times d added to the first term gives you the nth term. Now the sum of the first n terms, that's what S sub n stands for. If you add the first n terms in an arithmetic sequence, you get n over 2 times the quantity a1 plus a sub n. So the first term plus the last term, that quantity times n over 2 gives you the sum of the first n terms of an arithmetic progression. So we want to memorize these two formulas here. Now let's go to the board and work some problems that are based on these formulas. Well, first of all, let's try this. Are these sequences arithmetic sequences? Let's just check and see. To go from here to here with addition, I would add negative 5. That is, 50 plus negative 5 is 45. 45 plus negative 5 is 40. So the answer is yes, this is arithmetic. And in fact, D, the common difference, is negative 5. So an arithmetic progression is one in which we add the same number each time. And that number can be a negative number or a fraction or whatever you want. Now let's look at our second one here. 1, 4, 9, 16. Well, what would I add to 1 to get 4? The answer is 3. What do I add to 4 to get 9? The answer is 5. So right away I can tell this is not an arithmetic progression. Let's just do one more. 9 plus 7 is 16. So since I don't add the same number each time to get the next term in the sequence, this is not an arithmetic sequence or arithmetic progression. So I have to say no, it's not. There is no common difference. It's some other kind of sequence, but it's not an arithmetic sequence. Okay, let's go to the next problem now, which we're given a certain amount of information about a sequence and asked to find a couple of terms. Suppose that the first term, a1, is 3, and the common difference, d, is 4. Can we find the nth term and the 24th term? Well, the nth term in an arithmetic progression is the first term plus n minus 1 times the common difference, d. So in this case, that will be 3 plus n minus 1 times 4. d is equal to 4, a1 is equal to 3. I'll multiply this out. I'll get 3 plus 4n minus 4, and that simplifies to 4n minus 1. So there's the nth term, 4n minus 1, the nth term of that progression. Now, I want to find the 24th term. That's a sub 24, so that will be 4 times 24 minus 1. Let's see, 4 times 4 is 16. 4 times 2 is 8, 1 is 9, minus 1. That's 95. So a sub 24, the 24th term of that sequence, is 95. So what I have here is this. If I'm given the first term and the common difference, then I can find the value of any term in an arithmetic progression. In this case, I was asked to find the nth term, so it simplifies down to 4n minus 1. So that tells me that I can find the 24th term by simply taking 24, multiplying by 4, and subtracting 1. That gives me 95 if I've done the arithmetic correctly there. Okay, let's go to another problem in which we're given a couple of terms in a sequence and asked for some other information. Here it is. Problem number 4. A sub 6 is equal to 17, and a sub 12 is equal to 29. Can we find a sub 1, d, and a sub 30? Well, let's see. A sub 6 is the first term, a1, plus 5 times d. So 5 times d, this is the n minus 1. If n is equal to 6, n minus 1 is equal to 5. And then a sub 12, that's equal to a1 plus 11 times d. Now I know that a sub 6 itself is equal to 17, and a sub 12 is equal to 29. So what I have here is a system of linear equations in two variables, a1 and d, which I can solve using any method I want. I think the easiest way would be to multiply this equation by negative 1 and add it to this equation. If I do that, I'll get 0a1. So let's see. I'll multiply this by negative 1. So I get negative a1 minus 5d equals negative 17. Add this equation to this equation, and I end up with 6d is equal to what? let's see, 2, 1. So D is equal to 2. So I end up with D is equal to 2 by solving this system of equations here for D. Now let's substitute D back into either one of these equations right here, and we'll find A1. So I'll take D, put it back in here, and I have A1 plus 5 times D is equal to 17. A1 plus 10 is equal to 17. So A1 must be equal to 7. So the first term is 7. The common difference D is 2. Now I can put these two things together and find the 30th term. It will be the first term 7 plus 29, that's n minus 1, times 2. So that's 7 plus, let's see, 2 times 9 is 18. So that's 58 plus 7, 65. Am I running out of room here? A sub 30 is equal to 65. Okay. So, in this case, I'm given the 6th term and the 12th term. Okay, I take the 6th term, that's A1 plus 5 times D. The 12th term is A1 plus 11 times D. Remember that this coefficient that you multiply by is always 1 less than the term number. So I get these two expressions. Now I know A sub 6 is 17, A sub 12 is 29. That gives me a system of linear equations in two variables, A sub 1 and D. I solve that, and I end up with D equal 2. Substitute back in, A1 is 7. That means I can find any term. In this case, the 30th term in particular is the first term plus 29 times 2. I multiply all that out, I get A sub 30 is equal to 65. So kind of a neat problem because we get to review systems of linear equations in two variables. Let's go to the next problem, which involves finding the sum of an arithmetic sequence. So I want to find S sub 100 for 5, 9, 13, and 17. So first of all, I have the first term is 5. I need the common difference. Let's just check to make sure that this is in fact arithmetic. Yes, if I add 4 each time, adding 4 to each term gives me the next term. Now my formula for S sub 100, S sub 100 will be 100 over 2 times A1 plus A sub 100. So the formula for the sum of the first n terms is n over 2, in this case 100 over 2, times the quantity A1, the first term, plus A sub n, the last term that I want. That is this n right here matches this and matches this. So first of all, let's find the 100th term. A sub 100 will be the first term 5 plus 99 times the common difference 4. Okay, so 4 times 9 is 36. 36 and 3 is 39. 5 plus 396 should be 401. So A sub 100 is 401. Now I'll substitute that back in here, and we end up with, let's see if am I going to go off the screen here? Can we go over to that side a little bit? There we go. Okay. So 100 over 2 is 50 times A sub 1 is 5 plus A sub 100 is 401. So I have 50 times 406. Let's see if I can do this. 30 and then 20. 20,300. Let me just check my sheet here and see if that's right. That's right. 20,300. Okay, so here's what you do to find the sum of the first 100 terms of an arithmetic progression. It's n over 2, so whatever the number is of the sum that you want, S sub 100 is going to be 100 over 2 times the sum of the first term plus the last term, where the last term is the term number that matches this number right here. So A sub 100 if I'm looking for S sub 100. So I took an extra step here and found A sub 100. It's the first term plus 99, that's 100 minus 1, times 4. Multiply that out, I get 401. That tells me that S sub 100 must be 50 times the first term, which is 5, plus A sub 100, which is 401. I add that, I get 406, multiplied by 50, 20,300. So that's a look at some information that's associated with arithmetic progressions.